Before time existed, before space had any direction, before light, sound, and matter, there was nothing. No stars in the sky, no planets in motion, no galaxies spinning in silence. Not even darkness existed because darkness needs space, and space did not yet exist. This is not a story that begins in space. This is a story that begins before space itself. The narrator slowly asks a question that has haunted humanity for centuries. How did the universe begin? For thousands of years, humans looked at the night sky and wondered where everything came from. Ancient civilizations believed the universe was created by gods. Some believed it always existed. Others thought it was born from chaos. Today, science offers a shocking idea. Scientists believe that everything we see, every star, every galaxy, every atom in the human body came from a single beginning. A beginning so strange, so powerful, that it changed nothing into everything. At the start of this story, there was no universe as we know it. No distance, no time, no before and after. Time itself had not yet started ticking. All the matter and energy of the universe was packed into a point smaller than an atom. This point was infinitely hot, infinitely dense. Physics breaks here. Human understanding ends here. The laws that control stars, planets, and galaxies do not work at this moment. The narrator explains this moment is called the beginning of time, and it is where our story truly begins. Imagine trying to describe nothing. It is impossible. There was no empty space waiting to be filled. There was no silence waiting to be broken. There was simply nothing. Then, without warning, something happened. Not an explosion in space, but an expansion of space itself. This moment is known as the Big Bang, but the name is misleading. There was no sound, no fireball exploding into darkness, because there was no darkness yet. The universe did not expand into space. It created space as it expanded. This single moment created time, distance, energy, and matter all at once. The universe was born. In the first fraction of a second, the universe expanded faster than the speed of light. This phase is called cosmic inflation. The universe grew from smaller than an atom to the size of a galaxy in less than a blink. This rapid expansion explains why the universe looks the same in all directions today. But this newborn universe was not calm. It was violent, chaotic, unimaginably hot. Nothing could exist in solid form, not atoms, not particles. Only pure energy filled the universe. As the universe expanded, it began to cool. Energy slowly transformed into particles. Particles formed the first building blocks of matter. Quarks appeared, then protons and neutrons. The first time the universe had substance, but it was still dark. There were no stars to shine, no planets to reflect light. The universe was filled with a thick fog of energy and particles. Light itself could not travel freely. This was a universe without vision. Hundreds of thousands of years passed. The universe cooled enough for the first atoms to form. Hydrogen and helium were born. For the first time, light was able to move freely through space. This ancient light still exists today. Scientists call it cosmic microwave background radiation. It is the oldest light in the universe, a silent echo from the moment of creation. This faint glow is proof that the universe had a beginning. The narrator pauses. If the universe began from a single point, what existed before it? Science has no clear answer. Some theories suggest multiple universes. Others suggest time itself began at the Big Bang, meaning there was no before. This mystery remains unsolved, and that is what makes the universe so powerful. As the universe continued expanding, gravity began its work. Tiny differences in density became important. Some regions had slightly more matter than others. Gravity pulled matter together, slowly, silently, over millions of years. The universe entered a long, dark phase. This period is known as the cosmic dark ages. There were no stars yet, no galaxies, only vast clouds of hydrogen and helium floating through space. But something incredible was about to happen. Gravity never sleeps. Gas clouds grew larger and denser. Pressure increased. Temperature rose. Deep inside these clouds, the first stars prepared to ignite. The universe was about to light up for the first time. But this moment did not happen quickly. Millions of years passed in darkness. The universe waited, and then finally the first stars were born. Nuclear fusion ignited inside their cores. Light burst into existence. The cosmic night ended. These first stars were massive, much larger than our sun. They burned bright and fast. They were the universe's first sources of light, heat, and structure. With them, the universe changed forever. Darkness was no longer absolute. The narrator emphasizes the importance of this moment. Without these first stars, nothing else would exist. No planets, no galaxies, no life, everything traces back to this moment. As stars continued to form, they grouped together. Gravity pulled them into massive systems. The first galaxies were born, spiral shapes, elliptical giants, chaotic clusters. The universe began to take shape. Structure replaced chaos. But creation always comes with destruction. Many of the first stars died in powerful explosions called supernova. These explosions spread heavier elements into space. Elements needed for planets, elements needed for life. The universe was no longer simple, it was becoming complex. The narrator returns to the central question, how did the universe begin? The answer is not simple. It is a story of mystery, energy, gravity, and time. A story written across billions of years, and humanity is only beginning to understand it. The universe continues expanding even today. Galaxies move farther apart, space stretches endlessly, but the echo of the beginning still surrounds us. In the faint glow of ancient light, in the atoms of our bodies, we are made from the universe itself. The documentary slows down. The narrator speaks softly. The universe began with a mystery, and that mystery still lives among the stars. Fade to black. A final line appears. To understand everything, we must first understand the beginning. The universe had begun, but this beginning was not calm, it was not slow. It was the most violent moment in all of existence. In the very first second after the universe was born, everything changed forever. This single second decided how the universe would look billions of years later. The narrator explains, to understand the universe today, scientists must go back to the first second of time. Because in that first second the rules of reality were written. At the moment just after the Big Bang, the universe was unbelievably hot, trillions of degrees. Nothing could survive, not atoms, not particles. There were no forces as we know them today. Gravity, electromagnetism, and nuclear forces were all united into one powerful force. Science calls this the unified force. This is a place where modern physics struggles. Equations fail, understanding fades. Human minds cannot fully imagine this moment. Then, as the universe expanded, something incredible happened. The universe began to cool, and as it cooled, the forces of nature started to separate. First, gravity broke away, then the strong nuclear force. Later, electromagnetism and the weak force. These forces would later control stars, planets, and life itself. But at this moment, the universe was still pure chaos. This period is called cosmic inflation. In less than a fraction of a second, the universe expanded faster than light. Space itself stretched violently. Tiny quantum fluctuations, small energy differences were stretched across the universe. These tiny differences would later become galaxies. Everything we see today began as microscopic vibrations in space. The narrator pauses to let this sink in. Every galaxy, every star, every planet, all began as tiny imperfections in the early universe. Nothing was perfectly smooth, and that imperfection made everything possible. After inflation ended, the universe continued expanding, but at a slower pace. The temperature dropped rapidly. Energy began transforming into matter. This process followed a simple rule: energy equals mass. Particles began to appear. First came quarks, the building blocks of matter. Quarks combined to form protons and neutrons. For the first time, the universe had ingredients for atoms. But the universe was still too hot for atoms to exist. Everything was smashed together in a dense plasma. Light itself could not travel freely. The universe was filled with glowing fog. Seconds turned into minutes. As the universe cooled further, protons and neutrons began to combine. This moment is called Big Bang nucleosynthesis. Hydrogen nuclei formed first. Then helium, tiny amounts of lithium. These simple elements would become the foundation of all future creation. Without this moment, stars could never form. The narrator explains that even today, scientists measure the amount of hydrogen and helium in the universe. The numbers match the predictions perfectly. This is one of the strongest proofs of the Big Bang. The universe left behind fingerprints of its birth, but the universe was still not visible. There were no stars, no galaxies, no light moving freely. The universe was silent and dark. This darkness would last for hundreds of millions of years. As time passed, electrons finally slowed down enough to attach to nuclei. Atoms were born. Hydrogen atoms filled the universe. For the first time, light was able to travel freely through space. This moment is called recombination. The universe became transparent. The light released at this moment still exists today. It surrounds us in every direction, invisible to human eyes but detectable by satellites. This is the cosmic microwave background. It is the oldest light in the universe, a photograph of the universe as a baby. The narrator emphasizes its importance. This ancient light shows tiny temperature differences. These differences match the early fluctuations caused by inflation. Once again, science confirms the story. The universe remembers its own birth, but questions remain. Why did inflation happen? What caused the Big Bang? Was it the beginning of everything or just the beginning of our universe? Some scientists believe our universe is one of many. A multiverse, countless universes being born and dying. Others believe time itself began at the Big Bang. There was no before, only the beginning. The documentary shifts tone. The narrator speaks carefully. Science does not yet have all the answers, and that is not weakness, that is the beauty of discovery. Every answer leads to deeper questions. As the universe continued expanding, gravity began shaping its future. Matter was not spread evenly. Some regions were slightly denser. Gravity pulled matter into these regions. Slowly, over millions of years, structure began forming. The universe entered the cosmic dark ages, a time with no stars, no galaxies, only cold hydrogen gas drifting through expanding space. The universe waited. Gravity continued its slow work. Gas clouds grew larger. Pressure increased at their centers. Temperatures rose. The universe was preparing for its next transformation. The narrator builds suspense. After hundreds of millions of years of darkness, something incredible was about to happen. The first stars were about to ignite. But these first stars would not be like the stars we see today. They would be massive, short-lived, extremely powerful. They would change the universe forever. Before the first star ignites, the narrator returns to the human perspective. Every atom in the human body was created by processes that began here. In the first second, in the first minutes, in the early universe, we are not separate from the cosmos, we are part of it. The universe is not random chaos, it follows deep laws. Laws written in the first moments of time. As part 2 comes to an end, the narrator leaves the audience with anticipation. The universe has been born, matter exists, light is free, but the cosmos is still dark. The next chapter will change everything. Final lines, the universe took its first breath, but it had not yet opened its eyes. Fade out, text appears next, the dark universe and the first light. The universe now existed, space was expanding, time was moving forward, matter was everywhere. Yet something important was missing. There was no light. For hundreds of millions of years after the Big Bang, the universe lived in complete darkness. This period is known as the cosmic dark ages. It was the longest night the universe has ever known. The narrator explains carefully. This darkness was not empty. It was not silent. The universe was filled with vast clouds of hydrogen and helium gas. These gases stretched across unimaginable distances. There were no stars to shine, no galaxies to glow, only cold gas drifting through an expanding universe. From a human perspective, this time feels impossible to imagine. A universe with no light, no colors, no shapes. If eyes had existed, they would have seen nothing. Yet this dark universe was full of potential. Everything needed for creation already existed. It was only waiting. Gravity was present from the beginning. It never stopped working. Even in darkness, gravity slowly pulled matter together. Tiny differences in density began to grow. Some regions had slightly more gas than others. That small difference changed everything. Over millions of years, gravity gathered gas into massive clouds. These clouds became larger and heavier. As they grew, their centers became denser. Pressure increased. Temperature began to rise. The universe was preparing for its first transformation. The narrator builds suspense. Nothing dramatic happened suddenly. No explosion, no flash of light. Creation was slow, silent, patient. These giant clouds of gas continued collapsing under their own gravity. At their centers, conditions became extreme. Temperatures reached millions of degrees. Hydrogen atoms began to move faster and faster. The universe was approaching a critical moment. Then, after hundreds of millions of years of darkness, the impossible happened. The first star ignited. Inside the core of this newborn star, nuclear fusion began. Hydrogen atoms fused together to form helium. This process released enormous amounts of energy. Light was born. For the first time since the Big Bang, the universe shined. The narrator pauses. This moment changed everything. Darkness was no longer absolute. The universe had opened its eyes. These first stars were unlike any stars we see today. They were massive, many times larger than our sun. They burned incredibly bright, but they lived short lives. Some existed for only a few million years. In cosmic time, that is a heartbeat. The universe's first stars are called population Roman 3 stars. They were made almost entirely of hydrogen and helium. No heavy elements existed yet. These stars were pure, simple, and extremely powerful. Their light began to travel through space. For the first time, the universe was no longer hidden. Light revealed structure. It showed distance. It created contrast between darkness and brightness. But these stars did more than shine. They transformed the universe. Their intense radiation changed the surrounding gas. They heated it. They ionized it. This process slowly ended the cosmic dark ages. The narrator explains this era is known as the epoch of reionization. Light from the first stars changed neutral gas into ionized gas. The universe became transparent once again. Light could now travel freely across vast distances, but creation always comes with destruction. The first stars burned their fuel quickly. When they reached the end of their lives, they did not fade quietly. They exploded. These explosions were called supernova. They were among the most powerful events in the universe. In a single moment, a star released more energy than the sun will produce in its entire lifetime. These supernova had a crucial role. Inside stars, new elements were created: carbon, oxygen, nitrogen, iron. When the stars exploded, these elements were scattered across space. The universe was no longer simple, it became chemically rich. The narrator emphasizes this truth. Without dying stars, planets could never form. Without dying stars, life would be impossible. Destruction was necessary for creation. As more stars formed and died, the universe changed. Gas clouds became enriched with heavier elements. New generations of stars formed. These stars were smaller, longer-lived, more stable. Stars began to group together. Gravity pulled them into families. The first galaxies were born. These early galaxies were chaotic. They did not have clear spiral shapes. They were messy, violent, filled with rapid star formation and frequent explosions. At the centers of many young galaxies, something mysterious formed: black holes. Some black holes grew massive. They consumed gas and stars. They shaped the galaxies around them. The universe was no longer uniform. It had structure, clusters, voids, patterns. From chaos, order emerged. The narrator shifts focus. Even though this happened billions of years ago, scientists can still study it. Powerful telescopes look deep into space. Looking far means looking back in time. The light from the first galaxies takes billions of years to reach Earth. When scientists observe this light, they see the universe as it once was, a universe being born. Evidence of the dark ages and first stars exists in the cosmic microwave background. Subtle signals reveal when the universe became ionized. Once again, the universe tells its story. The narrator speaks with wonder. The universe was not designed for life. Yet through simple laws it created complexity, from gas to stars, from stars to galaxies, from elements to planets. The dark ages were not empty or meaningless. They were essential. Without darkness, light has no meaning. Without waiting, creation has no value. As the universe continued evolving, galaxies grew larger. They collided, merged, changed shape. The cosmos became a vast web of matter and energy. The narrator returns to humanity. Every element in the human body was forged in ancient stars. The calcium in bones, the iron in blood, the oxygen we breathe, all born in stellar fires. Humans are not visitors in the universe. They are the universe becoming aware of itself. As part 3 comes to a close, the narrator builds anticipation. The universe now has light, stars are shining, galaxies are forming, but something even more complex is coming. Final lines: from darkness, the universe created light, from light, it created structure, and from structure, it will soon create worlds. Fade to black. Text appears: the universe was no longer dark. Stars were shining. Light was traveling freely through space. The long night had ended, but the universe was still young. It was wild, unstable, full of motion. This was the era when the universe began to organize itself. This was the birth of galaxies. The narrator explains: after the first stars ignited, gravity continued its silent work. Stars were not evenly spread across space. Some regions had more matter, some had less. Gravity pulled stars and gas together. Slowly, over hundreds of millions of years, great cosmic cities were formed. These cities were galaxies. A galaxy is not just a group of stars. It is a system: stars, gas, dust, dark matter, all bound together by gravity. Some galaxies are small, some are enormous. Each galaxy tells a story of growth, collision, and change. The first galaxies were very different from the ones we see today. They were chaotic. Stars formed rapidly and died quickly. Explosions were common. These galaxies burned bright but lived dangerously. The narrator pauses. To understand galaxies, scientists had to understand something invisible, something that does not shine, something that cannot be seen directly: dark matter. Dark matter makes up most of the mass in the universe. It does not emit light. It does not absorb light. Yet its gravity shapes everything. Without dark matter, galaxies could not exist. Long before the first stars, dark matter began forming invisible structures. These structures acted like cosmic skeletons. Normal matter fell into these skeletons. Gas followed gravity. Stars followed gas. Galaxies were born inside dark matter halos. The universe began to look like a giant web. Filaments of galaxies stretched across space. Between them were vast empty regions called voids. This structure is known as the cosmic web. The narrator describes the scale. Billions of galaxies, each with billions of stars, all connected by gravity across unimaginable distances. The universe was no longer random, it had structure. As galaxies grew, something strange happened at their centers. Matter began falling inward, gas spiraled faster and faster. The center became dense and violent, and something extreme was born, a black hole. At first, black holes were small, formed from the collapse of massive stars. But some black holes grew rapidly. They consumed gas. They swallowed stars. They merged with other black holes. Soon, at the center of many galaxies, enormous black holes existed. These were supermassive black holes, millions to billions of times heavier than the sun. The narrator emphasizes a shocking fact. Almost every large galaxy has a supermassive black hole at its center, even our own Milky Way. These black holes are invisible, but their effects are powerful. As matter falls into them, it heats up. It glows. It releases vast energy. Some galaxies became extremely bright. Their centers shone like beacons across the universe. These objects are called quasars. Quasars are among the brightest objects ever observed. They are powered by feeding black holes. From billions of light years away, their light still reaches us. They are ancient signals from the early universe. But black holes do more than consume. They shape galaxies. Powerful jets of energy shoot out from their centers. These jets heat surrounding gas. They can stop new stars from forming. The narrator explains, black holes help control galaxy growth. Too much star formation can destroy a galaxy. Too little can stop its evolution. Black holes keep balance. Galaxies did not evolve alone. They interacted, they collided, they merged. When galaxies collide, stars rarely crash into each other. There is too much space. But gravity reshapes everything. Gas clouds compress. New stars are born. Collisions can transform galaxies. Spiral galaxies can become elliptical. Small galaxies are absorbed by larger ones. Growth happens through destruction. The universe was violent in its youth. Galaxies constantly changed shape. Nothing was permanent. The narrator shifts perspective. Over billions of years, galaxies slowly became calmer. Star formation slowed. Galaxies matured. Some became quiet and stable. The Milky Way is one of these mature galaxies. It formed from many smaller galaxies. It still carries scars of ancient collisions. The universe now had variety: spiral galaxies with graceful arms, elliptical galaxies like giant stars, irregular galaxies with no clear shape. Each type formed through a different history, but despite this diversity, the same laws ruled everywhere. Gravity, energy, time. The same physics shaped every galaxy. The narrator reminds the audience. When scientists look deep into space, they look back in time. The light from distant galaxies left them billions of years ago. Telescopes are time machines. By studying ancient galaxies, scientists see how structure formed. They test theories. They confirm predictions. Once again, the universe tells its story through light. The universe had now reached a critical stage. Galaxies existed. Stars were forming. Heavy elements filled space. The conditions for planets were approaching, but planets were not yet common. Most stars were still unstable. Radiation was intense. The universe was not ready for life. The narrator builds anticipation. Before life could exist, the universe needed calm. Stars needed to become stable. Galaxies needed balance. Time continued forward. Billions of years passed. Galaxies evolved. The universe expanded. The cosmos was preparing for something special, something small, something rare, something fragile. The narrator concludes Part 4 with a powerful reflection. From nothing, the universe created structure. From chaos, it created order. From darkness, it created light. Final lines: the universe learned how to build cities of stars, and within those cities it would soon begin to build worlds. Fade to black. Text appears: the universe was growing older. Galaxies had formed. Stars were shining across space. Black holes ruled galactic centers, yet something was still missing. The universe had light, it had structure, but it did not yet have the ingredients for life. The narrator explains a simple truth. Life cannot exist without elements, not just hydrogen and helium. Life needs carbon, oxygen, nitrogen, iron, calcium. But these elements did not exist at the beginning. The early universe was simple, too simple for life. So the universe had to learn how to create complexity. And it learned this inside stars. Stars are not just glowing balls of gas, they are cosmic factories. Deep inside their cores, powerful reactions take place. Hydrogen atoms collide and fuse, they become helium. This process releases energy, that energy makes stars shine. For most of a star's life, this balance continues. Gravity pulls inward, energy pushes outward. The star remains stable, but stars do not live forever. As stars age, their fuel begins to run out. Hydrogen becomes scarce. The balance slowly breaks. Gravity starts to win. In small and medium stars like our sun, the ending is gentle. They expand into red giants. They shed their outer layers. They leave behind glowing shells of gas. At their center remains a white dwarf. But massive stars live very different lives. Their endings are violent, and they change the universe forever. Inside massive stars, fusion continues further. Helium fuses into carbon, carbon into oxygen, oxygen into neon. Layer by layer, heavier elements are created. The star becomes like an onion. Each layer burns a different fuel. At the center, iron is formed, but iron is special. Iron does not release energy when fused. When iron appears, the star is in danger. The narrator slows the pace. Once iron builds up, the star cannot support itself. Fusion stops. Energy fades. Gravity takes control. In seconds, the core collapses. Matter crashes inward. Temperatures rise beyond imagination. Then everything rebounds. The star explodes. This explosion is called a supernova. It is one of the most powerful events in the universe. For a brief moment, a single star can outshine an entire galaxy. During a supernova, extreme conditions exist. Temperatures reach billions of degrees. Pressures crush atoms together. New elements are created instantly. Gold, silver, uranium, elements that cannot form inside normal stars. The narrator emphasizes a powerful idea. Every piece of gold on Earth was created in the death of a star. Every atom of iron in human blood was forged in a supernova. The explosion scatters these elements across space. They mix with gas and dust. The universe becomes enriched, complex, alive with possibility. But supernovae are not the only creators. When neutron stars collide, they create even heavier elements. These rare events shake space itself. They send ripples called gravitational waves. The universe speaks through vibration. Over billions of years, countless stars lived and died. Each generation enriched the universe further. Gas clouds became filled with heavy elements. The raw materials for planets were ready. The narrator shifts focus. The universe now had everything needed for complexity. But complexity does not guarantee life. Conditions must be just right. New stars began forming from enriched gas clouds. Around these stars, disks of dust and gas appeared. Inside these disks, tiny particles collided. They stuck together. They grew. Dust became rocks. Rocks became worlds. Planets were born. Some planets were too hot. Some were frozen. Some were destroyed by radiation. But a few existed in the perfect zone. Not too close, not too far. The universe was experimenting, trying countless combinations. Most failed. A few survived. The narrator reminds the audience, the universe is not designed for life. Life is a rare outcome, a fragile result of balance. Heavy elements allowed planets to have solid surfaces. They allowed atmospheres to form. They allowed chemistry to grow complex. Carbon became the backbone of molecules. Oxygen allowed energy reactions. Nitrogen stabilized systems. Water became the universal solvent, but life did not appear immediately. For billions of years, planets were lifeless. The universe waited again. The narrator reflects. Creation in the universe is slow. It requires patience. Stars take millions of years to form. Elements take billions of years to spread. Life is not rushed. Somewhere in a quiet galaxy around an ordinary star, a small rocky planet cooled. Oceans formed. Chemistry began to change. But this story belongs to another part. For now, the universe had finished preparing the stage. The narrator brings the focus back. Everything humans are made of comes from ancient stars. Bones, blood, breath. We are literally stardust. This is not poetry. This is science. The universe did not know it was creating life. It followed simple laws. Fusion, gravity, energy. Yet from these laws came awareness. The narrator speaks softly. The universe learned to create complexity by learning how to let stars die. Without death, there is no creation. Without destruction, there is no future. The universe understands this balance. As galaxies matured, star formation slowed. The universe became calmer, more stable, safer for fragile worlds. The time of violent creation was ending. The time of quiet evolution was beginning. The narrator closes part 5 with anticipation. The elements are ready. The planets are forming. The conditions for life exist. Final lines: from the ashes of dying stars, the universe created the ingredients of life, and somewhere among the stars, those ingredients would soon begin to awaken. Fade to black. Text appears. Next, the birth of solar systems and new worlds. The universe was now rich. Galaxies were mature. Stars were shining steadily. Heavy elements filled space. The chaos of the early universe had begun to slow. This was the moment when something new could finally form. Worlds, the narrator explains. Stars are born inside giant clouds of gas and dust. These clouds are called nebulae. They drift silently through galaxies for millions of years. Cold, dark, calm, but gravity is always waiting. When a nebula becomes dense enough, gravity takes control. The cloud begins to collapse. As it collapses, it starts to spin, slowly at first, then faster. At the center of this spinning cloud, pressure and temperature rise. A new star is born, but the story does not end with the star. Around the newborn star, leftover gas and dust remain. This material forms a flat, spinning disk. This is called a protoplanetary disk. Inside this disk, planets begin to form. The narrator slows the pace. Planet formation is not fast. It is quiet, gentle, patient. Tiny dust grains collide. Most collisions do nothing. Some particles stick together. They become slightly larger. Over thousands of years, dust becomes pebbles. Pebbles become rocks. Rocks become planetesimals. Gravity now helps. Larger objects pull in smaller ones. They grow faster. They grow heavier. Some become rocky planets. Others become gas giants. The result depends on distance and material. Closer to the star, it is hot. Only rock and metal survive. This is where terrestrial planets form. Planets like Earth and Mars. Farther from the star, it is cold. Gas can survive. Huge planets form, Jupiter-like giants with thick atmospheres. The narrator explains that every solar system is different. Some have many planets, some have few, some are chaotic, some are stable. Early solar systems are violent places. Planets collide, orbits shift, worlds are destroyed. Many planets never survive. They fall into their stars. They are thrown into deep space. But some systems find balance. Orbits stabilize, collisions slow. A planetary family is born, the narrator reflects. The universe does not design solar systems carefully. It experiments again and again. Most experiments fail, a few succeed. Around billions of stars, trillions of planets form. Some are frozen, some are burning, some are crushed by gravity, but a small number exist in a special region. The habitable zone. This is the region where liquid water can exist. Not too hot, not too cold, just right. Water is rare and powerful. It allows chemistry to grow complex. It allows molecules to interact. It allows life to begin. But even in the habitable zone, life is not guaranteed. A planet needs stability, a protective atmosphere, a magnetic field, time. The narrator emphasizes time. Life does not appear quickly. It requires billions of years of calm conditions. Most planets never get this chance. Asteroid impacts destroy them. Radiation strips their atmospheres. Gravity pulls them apart. The universe is dangerous. Life is fragile, but somewhere conditions align. The narrator shifts focus. In one spiral galaxy around an average star, a small rocky planet forms. At first it is molten, volcanic, hostile. Gradually it cools, oceans form, the surface stabilizes, the atmosphere thickens. Asteroids bring water. Comets bring organic molecules. Chemistry becomes richer. This planet is not special yet. It is just another world, but it survives for millions of years. Then billions, the narrator pulls back. This process happens everywhere, across galaxies, across time. Astronomers today search for these worlds. They find planets orbiting distant stars. These are called exoplanets. Some are larger than Jupiter. Some are smaller than Earth. Some orbit dangerously close to their stars. Some exist in darkness. The diversity is astonishing. Hot Jupiters, super-Earths, ocean worlds, lava planets. No two systems are exactly the same. The narrator explains how planets are detected. Stars wobble under gravitational pull. Planets block starlight as they pass. Tiny signals reveal massive worlds. Each discovery changes our understanding. The universe is filled with planets. Worlds are common, but life, that remains unknown. The narrator builds suspense. Just because planets exist does not mean life exists. Life requires more than a planet. It requires balance, protection, stability. Many planets lose their atmospheres. Many are bombarded by radiation. Many freeze, many burn. The universe is not kind. Yet life does not need kindness. It needs opportunity. Somewhere, chemistry crosses a line. Simple molecules become complex. Self-replication begins. But that story belongs to another chapter. The narrator returns to the cosmic scale. The universe now contains stars, planets, elements, energy. Everything needed for life is present, but life is not inevitable. It is rare, precious. The formation of planets marks a turning point. The universe is no longer just expanding. It is building homes. Each planet is a possibility. Most will remain silent. A few may awaken. The narrator ends part 6 with reflection. The universe learned how to build stars, then it learned how to build worlds, and within those worlds it created the possibility of life. Fade to black, text appears. Next, Earth, a rare cosmic miracle. The universe had created countless worlds, planets of fire, planets of ice, planets crushed by gravity. Most of them were silent, cold, lifeless. But among trillions of worlds, one planet followed a very different path. Small blue world, Earth. The narrator begins softly. Earth was not born special. In the beginning it was violent. Molten rock covered its surface. Volcanoes erupted endlessly. Asteroids struck without warning. The young Earth was hostile, deadly, unstable. For millions of years, Earth was a world of fire. The sky was thick with toxic gases. No oxygen, no oceans, no life. Yet even in this chaos, something important was happening. Earth survived. The narrator explains. Earth formed at just the right distance from its star. Not too close where water would boil away. Not too far where water would freeze forever. This region is called the habitable zone, but distance alone was not enough. Earth had another gift, a strong magnetic field. This invisible shield protected the planet from deadly solar radiation. Without it, Earth's atmosphere would have been stripped away. Life would never have had a chance. Slowly, Earth began to cool. The surface hardened. Water vapor condensed. Rain fell for millions of years. Oceans were born. The narrator pauses. Water changed everything. It allowed chemistry to become complex. It allowed molecules to move, collide, and react. Earth was ready for something new. Deep within the oceans, far from sunlight, life began. Not plants, not animals, something far simpler. The first life forms were tiny, single-celled organisms, invisible to the naked eye. Yet they carried a powerful secret. They could copy themselves. The narrator emphasizes this moment. Life is not defined by size or intelligence. Life begins with replication. These early organisms lived in harsh conditions. They fed on chemical energy. They survived near underwater vents. They multiplied slowly. For billions of years, life remained simple. No eyes, no brains, no movement, just survival, but evolution never stops. Small changes occurred, random mutations. Most failed. Some survived. Then one of the most important events in Earth's history occurred. Some organisms learned how to use sunlight. This process is called photosynthesis. Using sunlight, water, and carbon dioxide, these organisms produced energy and something else. Oxygen. At first, oxygen was poison. It killed many early life forms. The planet faced a crisis, but some organisms adapted. They learned to use oxygen. This new process released far more energy. Life became more powerful. The atmosphere changed. Oxygen filled the sky. Earth transformed. The narrator highlights the importance. Without oxygen, complex life is impossible. No animals, no humans. Time continued. Millions of years passed. Life became more complex. Cells joined together. Multicellular organisms appeared. Life moved slowly at first. Then suddenly it exploded. This period is known as the Cambrian explosion. In a relatively short time, many new life forms appeared. Creatures with shells, with eyes, with movement. The oceans filled with life. Predators and prey evolved together. Nature became competitive. Life eventually moved onto land. Plants appeared first. They transformed the planet again. They stabilized the soil. They produced oxygen. Animals followed. Insects, reptiles, mammals. Earth became a living world, but evolution is not a straight path. It is shaped by disasters. Asteroids struck. Volcanoes erupted. Climate changed. Mass extinctions occurred. Most life disappeared again and again. One of the most famous extinctions ended the age of dinosaurs. A massive asteroid struck Earth. Darkness covered the sky. Temperatures dropped. Life suffered, but extinction created opportunity. Mammals survived. They adapted. They evolved. The narrator reflects. Life does not seek perfection. It seeks survival. Over millions of years, mammals grew more complex. Brains became larger. Social behavior developed. In one branch of this tree, something unusual happened. A species began to ask questions. Humans appeared. Humans were not the strongest, not the fastest, but they could think. They could imagine. They could understand. The narrator emphasizes the irony. The universe created humans from stardust, and humans began to study the universe. Every atom in the human body came from ancient stars. Every breath connects us to cosmic history. Humans looked at the night sky. They asked the same question again. How did all this begin? Earth is not just a planet with life. It is a record of the universe's journey from chaos to complexity, from simplicity to awareness, but Earth may be rare. The universe is vast, yet life appears fragile. Scientists search for life beyond Earth. They look for water, for oxygen, for chemical imbalance. So far, Earth remains unique, but the search continues. The narrator speaks softly. If life exists elsewhere, it will follow the same rules, born from stars, shaped by time. As Part 7 comes to an end, the focus shifts outward. Earth is one small world in a vast universe, yet it carries consciousness, memory, curiosity, final lines. From silent atoms, the universe created life. From life, it created minds, and through those minds, the universe began to understand itself. Fade to black. Text appears. Next, the future of the universe. How will it all end? The universe began with a mystery. From nothing, everything was born. From silence, time started to move. From darkness, light appeared. Now, after billions of years, the universe continues to expand. But one final question remains. How will the universe end? The narrator speaks slowly. Nothing in the universe lasts forever. Stars are born, stars die. Galaxies collide, galaxies fade. Even time itself may have an ending. To understand the future, scientists study the present. They observe distant galaxies. They measure how fast space is expanding. What they discovered changed everything. The universe is not slowing down, it is expanding faster. Something unknown is pushing space apart. Scientists call it dark energy. Dark energy is invisible. It does not emit light. It does not absorb light. Yet it controls the fate of the universe. The narrator explains, dark energy makes up most of the universe. More than matter, more than dark matter, it stretches space itself. Because of dark energy, galaxies are moving away from each other faster and faster. The universe is not collapsing, it is pulling itself apart. This discovery changed how scientists think about the end. There are several possible futures. Each one is dramatic, each one is final. The Big Freeze, a cold and silent end. The first possible ending is called the Big Freeze. In this future, the universe continues expanding forever. Galaxies move farther apart. Eventually, distant galaxies disappear from view. The night sky grows darker. Stars continue to burn, but stars have limited fuel. One by one they die. No new stars are born. Gas becomes too spread out. Star formation stops. After trillions of years, only dead stars remain. White dwarfs, neutron stars, black holes. Planets drift through space in darkness. No warmth, no light. The universe becomes cold, near absolute zero. Time continues, but nothing happens. Eventually, even black holes evaporate. They slowly lose energy. They disappear. The universe becomes empty, dark, silent. This is the Big Freeze. The Big Crunch, a violent collapse. Another possibility is called the Big Crunch. In this scenario, dark energy weakens. Gravity takes over. Expansion slows, then stops. The universe begins to collapse. Galaxies move closer. Temperatures rise. Stars collide. Radiation fills space. Everything rushes inward. Space shrinks. Time behaves strangely. Eventually, the universe returns to a single point. Just like the beginning, some scientists wonder, could another universe be born from this collapse, a new Big Bang, a cycle without end? This idea remains uncertain, but it suggests the universe may be reborn. The Big Rip, when space itself tears apart. The most dramatic ending is called the Big Rip. In this future, dark energy grows stronger, much stronger. At first, galaxies are torn apart. Then solar systems break, planets drift away from stars, stars are pulled apart. Eventually, even atoms cannot hold together. Space stretches so violently that everything is destroyed. Matter itself is ripped apart. There is no darkness, no silence, no structure, only expansion until nothing remains. The narrator pauses. This is the most extreme ending, but it is still possible. Which ending is correct? Scientists are still unsure. Data improves, measurements become more precise. So far, the Big Freeze seems most likely, but the universe has surprised us before. The narrator reflects. Humanity exists at a special moment, early enough to see galaxies, late enough to understand physics. In the far future, intelligent beings may see a very different universe. A darker sky, fewer clues. The universe is changing, and we are part of that change. The narrator shifts focus to humanity. Humans are made of stardust, temporary, fragile, yet humans ask eternal questions. Why does the universe exist? Why do laws exist? Why is there something instead of nothing? Science answers many questions, but not all. Some mysteries may never be solved, and that is okay. The universe does not promise answers, it offers wonder. From the first second to the final moment, the universe follows simple rules. Gravity, energy, time, yet from these rules came galaxies, stars, planets, life, consciousness. The narrator speaks softly. The universe began as a question and it may end as one. But in between, something remarkable happened. The universe became aware of itself. Through human eyes, the universe looks back at its own beginning. Through human minds, it imagines its own end. That may be its greatest creation. The narrator delivers the final reflection. Whether the universe freezes, collapses, or tears apart, its story has already been extraordinary. Final lines. From nothing, the universe was born. From silence, it learned to speak. From darkness, it created light. And through us, the universe learned to ask why. Fade to black. Soft cosmic music. Stars slowly disappear. Next, the birth of galaxies and cosmic giants.